Good morning, good evening, good afternoon, everyone, based on your time zone. Welcome in Salesforce Epics Hour. My name is Amit. I'm your host and the founder of the Epics Hour. And today we are going to talk about the mastering and Epics collection. And we have a special guest from the Salesforce Developer Advocate team, Felipe, with us. And let me hand over to him for the presentation and his introduction. Hand over to you.
Yeah, thanks, Amit, and thanks everyone for joining in. My name is Felipe Ozil. I'm a developer advocate at Salesforce. I've been in Salesforce for the last 5 years. And what my job entails on a day-to-day basis is to explore our different technologies and share the latest innovations that we have, and also best practices around the different aspects of our technologies. Things like Apex, but also Lightning Web Components and other tools like Lightning Design System, functions maybe one day, and all of these things. So you can find resources that we create, of course, on our brand new developer website, and you can also follow us online. We have various social media handles. I'm particularly active on Twitter, so here's my Twitter handle @PhilipOzil if you have questions. All right. Now, on today's agenda, we're going to talk about Apex collections. That's something all of us who write Apex use every day, but I think hopefully today you will learn a few things about collections, because there are a lot of aspects of collections that people may not know about. And I'm here today to dig and explore a bit those different things. So we're going to divide the presentation into 3 sections. First, I'm going to talk about objects, because objects are part of what compose the collections. And then I'm going to talk about the different collection structures and what are key differences between them. Then I'll talk about iterating on collections. So we'll explore different options, see some limitations that there are with iterations, and we'll finish with list sorting. This seems like a pretty simple topic, but it is not, and we'll see why. All right. That being said, I will try to stop from time to time to see if there are questions, but I would like to invite you just to watch and share your thoughts in the chat. All right. This presentation will be mostly driven by slides, but I will share code in the slides, and sometimes also I will go into VS Code to run a bit of code to show you some examples. All right. Let's go and then start with objects and collections. First of all, I think it's a good thing to start with a reminder. Everything that you work with in Apex is an object. This is because Apex is originally based on the Java language, and in that Java language, everything is an object. So whether you're talking about the basic primitive types like integers, dates, strings, all of these are objects, but also collections like list, set, map, sObjects, account, etc. They're all actually objects, and even your custom classes are inherit from object. Although you did not need to specify it when you create a new class, it's actually something that is enforced. These are new classes are inheriting from object. And the object signature is actually quite simple in Apex. In Java, it's a bit more complex, but there are 3 methods that are enforced that are part of the object signature. There is the equals method, the hasCode method, and the toString method. I'm not going to talk too much about toString, but I'm going to talk more about equals and hasCode later on in this presentation, because they are extremely important when dealing with collections. So I'm going to explain a bit more what they do, some tips and tricks when working with custom objects and collections. So I'll get back to those later on. Now that we have covered the basic structures of objects, let me run now into collections. I think most of you already know this, but it's interesting to just do a recap also here before going into the heart of the topic. There are 3 types of collections that you can use in Apex: list, set, and map. They each have their own unique use and properties. Lists is simply just an ordered list of non-unique elements. This means that you can have twice the same element in a list, no problem. You can also have null elements, no problem. Sets, however, are a bit different. They behave a bit like a list, but they are only unique elements in the list. If you try to add twice the same element to a list, it will only appear once. To a set, sorry, it will only appear once in a set. So using sets is actually very convenient when you need to sort a large list and just retain unique elements. You can just switch from a list to a set to grab those unique elements. However, sets are not ordered, so that can also be a problem. Then there are maps. Maps are simply a dictionary with key and values, and you can control the types of the keys and types of the values. Now, what's interesting with these different types is that the list and set are actually interoperable to a certain point. They share some common constructors. So for example, you can switch from a list into a set by using a special constructor. If you do a new set with a list as a parameter, you can convert a list into a set and vice versa. There are also a certain number of methods which let you do operations on lists and sets with the opposite type. So for example, if you're working on a list, you can do add all with a set element, and you can jump from one type to the other. There are a number of them. I haven't listed all of them here. Of course, all of this is documented. Then there's an interesting part that is very critical to what our content is today, the equality checks. There are a number of methods for list, sets, and map which require to check for specific elements. Like, for example, the contains method. When you work with the contains method for a list or for a set, you need to figure out what means an equality between the element that you're searching for and the list elements. And depending on the collection type you're using, we're using different methods to do this check. On the list, we're always using the equals method. You remember that's the method from the object type. But when working with sets and maps, we're no longer using the equals method. We're first using the hasCode method and then equals. And I will share a practical example about the key distinctions there are between those methods. Now, obviously, the list is the only type that can be sorted, and more on that at the end of the presentation. And more, I would say, a bit more rare, you can actually iterate on lists and sets, but of course, you cannot iterate on maps. So that's the general structure of the different collections. As I mentioned, some of them are interoperable, and this means that you can actually do a bit of casting between the different types. So let's take a code example here. Line 1 and 2, we create a parent class and we create a child class, which extends the parent. And here after that, we're testing different scenarios of casting the different types. So for a list, it's fine. If you have a list of children, you can assign it to a list of parents. The casting is valid. The list will still be, this assignment can work in line 6. When you're working with a map, this also works, provided that you only use casting on the value field. So you can only work with value types which are compatible or can be casted. So here, for example, when you look line 9 and 10, you can replace the child here by a parent. This works, but you couldn't do that if you were working with the key values or key types. Here I've kept string in this example, but you could not have a key which is a child converted or cast to a key that is a parent. This only works for the value of the map. So this can be convenient when working with large sets. Instead of recreating everything and just adding elements manually, you can do some level of casting. What is, I think, surprising and not necessarily known is that you cannot do the same thing with a set. So you can do this with a list, but you cannot do this with a set. That's the last example here at the bottom, line 13 and 14. You cannot get a set of child elements and assign it to a set of parents. This will result in a runtime error with an illegal assignment error. That's the way the runtime works. It cannot cast it. Now, further on these different types, I want to talk about how equals and hasCode work. Remember, these are methods that are defined at the object level. And I'm going to start with the one that I think the fewer people work with, that's hasCode. So all of this actually is pretty well defined in the Java documentation. There are some lightweight documentation in the Apex developer guide, but it's actually copy pasted from the Java developer guide, the Java doc, sorry. So if you want to learn more about these two things, you can directly go ahead and check for the object hasCode and object equals method in the Java documentation. You'll find more details than there are in Apex. First of all, let's start with hasCode. So hasCode gives you an integer, which is supposed to represent a unique hasCode for an object instance. So take, for example, an account. If you grab the hash code of this account, this will try to get you a unique number which describes all the different combination of different fields of this object instance. Depending on the object, of course, the method is calculated differently. Some of the fields of the objects may be omitted in a way when you calculate the hash code. So that's what I'm saying. It's pseudo unique. It's not necessarily unique. There might be objects with different values that can return the same hash code. The idea here is that we try to generate a quick identifier for an object, which lets us work with set and maps, because set and maps rely on unique elements. And to figure out quickly whether an element is unique, we work with hash codes. And the way this works is that generally, first, we check for a hash code. If we find duplicate hash codes for objects, instances, this is called a hash code collision. And this can happen, it's fine. And in that case, if there is a collision between two hash codes, the Apex engine will actually fall back to the equals method. Now, the equals method works as well, but it's actually something that is a bit more costly than running a hash code call, because the way the equals method works, it will do a bunch of comparison between the objects. There's going to be a bit of conditional logic behind it, which is more expensive than simply comparing two integers that were retrieved with hash code. There are a bunch of rules when working with hash codes, and one of the key rule, I think, is that when you have two objects with instances which are equals, or which return true when you call equals method, they need to have the same hash code. But again, remember that the opposite is not right. If the two objects can return the same hash code, but they're not necessarily equals. And one thing that is also something ideally, it's not always true, whenever you change a property for an object, for an object instance, the hash code should change. It's not always the case, but in most cases, it should be true. Finally, let's talk about the Boolean type. The equals method. The equals method lets you compare the current object instance and another object instance. Now, what's important to know about this is that you can compare objects with different types. So, for example, there's nothing that prevents you from comparing an account with, I don't know, a string, for example, or comparing an account with an opportunity, an account with a contact. That's something people tend to forget. The equals method works on multiple types. So one of the first things you want to check when you work with a custom equals method implementation is to check whether the two objects have the same type. And in some cases, it's perfectly fine to compare objects which do not have the same type. I'm going to show you an example about a case in which we can compare objects with different types. So once we have compared the two different types, we then compare the field values. And there are a set of rules for that, depending on the objects that you're using. You can just cycle through all the field values. And as soon as there's a field which differs, you can return a false value, which means the two objects aren't equal. Or you can also skip some of them, but that's generally not recommended. Again, I want to stress out the fact that the equals method is not being used when you run operations on set and map unless there's a collision on the hash code. All right, now let's try to see a practical example of what this means. I'm going to jump to VS Code, and we're going to take a look at some code here. So let me just increase a bit the font size so that everyone can see it. And I'm going to start looking at an example, and I will actually ask everyone to pay attention to it. So I actually make sure it's quite big. There we go. There we go. All right. So this is something that was posted on the Salesforce Stack Exchange, and this was like a kind of a puzzle for the user who posted this question. The code is pretty simple. We create an ID instance here. We create a map of string, and we put two strings in the map, and then we try to retrieve the string, an element by using the account ID value that we just had before. And no, there's no trap here. The key here is exactly the same here for the ID and the value that you put in the map. So this was the puzzle. What happens when you run this, I think you may guess what may happen, but the trick is when you run this here, I'm going to actually do that. I have a little script here, which will execute this bit of code in anonymous Apex mode. And in second, you'll see that line 4 returns null. So our debug statement here is actually returning null. This thing here is not able to retrieve our value from the map. So at this point, people had different theories about what was going on. And the way things are working here has nothing to do with the different ID types, because this was the first ID people had. People were wondering whether this is because the ID can be encoded in a 15 characters or 18 character string, but this is actually not the problem. The problem was with the way lists and maps work and the way hash codes work. So let's try look at this bit by bit. First, we start with an account which is created here, and we can actually grab here the hash code of this thing here and see what this is. And then later on, we can also take a look at our string value here and try to look at the hash code of our, sorry, forgot to type this. This is not going to work well. And we can also take a look at the string value and get its hash code. And you'll see exactly what's the problem. Oops. If I run this again, we're going to see that these actually, yeah. This is what? Why is it not happy with my hash code? Well, come on, what's the problem with that? Schedule C, right? Doesn't like my hash code method. Well, I can tell you the problem is that the try again that. There we go. No. Well, for some reason this doesn't work, but the thing is, essentially the ID value here isn't generating the same hash code as a string. Now the two things are equal. So if you compare this, I'm going to do this the other way around. If you try to do an equals method, oops, and if you compare this with a string, you'll find that this is actually equal. So you see we have a true on line 2. These two things are equal. So whether you're working with an ID or a string, these are actually equal. But if I were to add the 18 character version of the ID, this is the 15 version, this will also return true. This is an example of how equal can behave with other types. We're comparing an ID with a string. Now, what I couldn't for some reason show you here is that, however, these two objects are equal, whether you're looking at the ID or the string. If I were to do account ID string here with the same value, these two objects are still equal, but they have different hash codes. So if I were to grab the hash code of my ID here, I would have a different value than I would have from my string here. And this is why my map is not able to retrieve my object. It's using a hash code instead of using directly the value here to retrieve the object. So in the case of this example, what I should do for this to work is actually to convert my map to an ID. And this would avoid the casting, and it would ensure that my types are retained and my hash codes are similar. Here you can see that this worked. If I simplify a bit the code now, if I remove this and this, we now have the right thing that is working because the ID isn't getting the same hash code than a string, it breaks the hash code to retrieve the element from the map. Now, this is a very simple example with an ID, but the same thing can happen with objects. So if I take the same example here, but this time I work with an account, and I'm doing a new account here with a name, for instance. Oops. Well, I can add it to my list here. So let's just say I have a string here, or actually an account string. I can actually add my account. So let's just call it ACC. It'll be easier. I can add my account here and keep a string here. And then I can try to get it later on here. So this works fine, right? This is still working. I'm still getting my key value here. But what happens now is that if I do the same thing, if I do if I add my account to the map and actually I change the value of my account. So for example, I changed the, if I add what, like a rating value, for example. I don't know about the fields for account. I'm not try to do something like that. Then I rerun the code. And at this point, I no longer find my account. This is because the fact that I've modified one of the fields of the object has changed the hash code. The rating field is used to generate the hash code of my object. And I can actually, this time, show you this by debugging the output of the hash code method. So let's just do that. Here, I'm going to get the hash code value here. And I'm going to grab the hash code again, just after modifying my account field. So this time, we're going to see why we have two different values. Why? Oh, well, yeah, I know. I figured out why I wasn't able to do it earlier. To get the hash code, you need to cast it to an object. So that's why I couldn't get it for the ID a couple of minutes ago. So changing the code, I cast my account to an object, and then I can call my hash code method. Doing this again here, and this time we'll be able to see the hash code. Sorry, I forgot about this. So now you can see here that I have two different hash codes. The first one is happening on line 2. Here we have an initial hash code at this point when we create the new object, but changing a field here, assigning the rating field here, modifies our hash code. And this is why at the end on line number 9, we're no longer able to retrieve our object from our map. So you can see here how important it is to have a strategy when working with objects, and also how important it is to have a proper hash code method. Of course, you cannot change the implementation of hash code for sObjects because these objects cannot be modified. But if you're working with custom objects or custom classes that you have defined, make sure you write a strong definition for hash code. So I'm not going to go a lot in details about how hash code works, but essentially it's doing some calculation based on different field values, and it's also multiplying by a prime number to make sure that there are as few possible collisions between those numbers. And in the end, you have a very large integer or a small integer, because you can also have negative values, which are supposed to uniquely identify object instances based on their field values. So that was the little side parenthesis about hash codes. Let me just check quickly the chat if there are questions. Oh, good point. Someone's mentioned that I can also use system.hashcode object to get the hash code of an object if I don't want to do the casting. So that's good. I didn't know about that. Pretty interesting. And someone also mentioned that there is a there was a known issue about hash code on the IDs which were broken. So okay, that's good. I didn't know about that. Learning things as well. So cool. That's it for objects and hash codes and equals method. Let me just go back now to the slides. So that was a quick overview about how hash codes and equals method works. Now let's talk about collections. I'm going to change a bit topic now. I'm going to talk about iterating on collections. I don't know in the audience if there are a lot of people who are familiar with that, but there is a way to iterate on a collection that's called an iterator. This is something that is not so often used in Apex, but it's actually super useful when you do Java, for example. And the way this works is based on two interfaces. There is the iterable interface and the iterator interface. And as I mentioned earlier, there are two types of collections that use it: lists and set. So list and set both implement the iterable interface. And this is the definition of this interface. This is just one simple method called iterator, which returns an iterator for that particular collection type. And the T here represents the object that is in the list or in the set. So it can be account, string, ID, whatever you want. But the idea is that we keep that type all along. It's the same for the entire schema here. And in the end, you get an iterator for the specific type. The iterator has two methods: hasNext and next. And when you look at Java, there are a bit more methods. For example, you can also iterate on the collection by going backward, and you can also modify the collection with the iterator. But in our case, in Apex, there's only one way to navigate. It's forward, and you cannot modify the collection because you only have those two methods when you're working with the iterator. So let's see how this works in practice. In the short code sample here, we have an example. We start by building a list of accounts here, and we call the .iterator that is coming from the Iterable instance. So our list here implements the Iterable interface, so we can call iterator, and we get an iterator on the account object. Here I'm calling it, which is a pretty common name for iterators. And after that, I can actually call my different methods, hasNext to making sure that I have a next element, and then calling it.next or iterator.next to get the next element in the list. And this returns an account for me. Now, there are some key advantages of using that instead of using a for loop, because of course you could simplify all of this code by doing for account a column my list. So that could be very simplified. Instead of having 6 lines here, you can do this in almost 2 lines. But using iterators has a few advantages, in particular around the read-only access. So the first thing here I want to highlight is that when you work with iterators and you pass, for example, an iterator to another function, for example, another package or something, you guarantee that you provide a read-only access to a collection. So if you function like in some sort of black box mode, and you don't necessarily trust the function that you're passing your list to, well, you can just provide an iterator to that other function instead of showing the entire collection. And this way, with the iterator, you can be sure that the other function cannot modify your collection. It will not be able with an iterator to add elements, to delete elements, or even to modify elements from the collection. The second thing here, which I've actually discovered while preparing this presentation, this is actually not happening in Java, but it is very specific to Apex. Using an iterator actually locks the collection in read-only mode. So as soon as you retrieve a handle to an iterator, so here line 2, you actually lock my list in read-only mode. So for example, if we're going to see that with an example, but if after retrieving my iterator here, I was trying to add an element or remove an element from my list, I will get some errors. Finally, something also very valuable, and which is, I think, specific to the way iterators work, the collection size can be actually calculated dynamically when working with iterators. Because of course you can create your own iterable resources. It's not always a list or a set. You can also create your own objects. And that's actually very handy when you work with APIs, for example, REST APIs and things like that. And anytime you need to do something that is paginated, it's good to have an iterator, because your hasNext function can be in fact a call to a remote API. So you can be actually calculating the new size of the collection, whether it has additional rows in the table, for example, or additional pages in a resource. So that's very handy. And it's actually why part of the reason why when you're working with batchable Apex, there are some iterators patterns behind it. You have to work with next and has next because you're working with large amounts of objects and you cannot run the entire operation in a single go. So that's something very handy. You can actually trigger some code here with next or has next in the background. So let's look at a little example of the thing that I mentioned, the read-only locking for the collection. So in this example now, we've created a simple list of integers and we're retrieving an iterator on this list. So we can call it.next, get the first element from our list, it.next again, second element of the list, it.next, third element of the list. But then at this point, for example, we can try to add something to the list. Well, that will fail actually. This will return a system final exception that will actually prevent you from modifying the list. And this is because the Apex runtime is available to detect that you have an iterator that is using the list at this point. So if you want to modify the list, what you can do is clear the reference to the iterator by assigning it null, for example, and then you can actually do your operation on the map by adding things, removing things, or whatever. That's something I think very few people know about, and it really came as a surprise to me. When you work on Java, again, the iterators do not work this way. You can still modify the collection, although it's not recommended. So that can be very handy. That's for iterating with collections. Any questions on iterating with collections? Well, before I jump into the next topic, list sorting, which will be actually the biggest part. It's quite complex to do list sorting. I don't see any questions at the moment, so I'm going to continue. But feel free to write them in the chat if you have any. All right, let's talk now about sorting lists, all types of lists. So most of the time, we do not have to sort lists ourselves because we are happy enough to have SoCal already integrated in Apex. So we can often do a SoCal query with some ordering clauses, which is very handy. But sometimes when we're working with things that are not sObjects, or sometimes we also don't have our objects persisted in the database yet, we have to do manual sorting in Apex. To do that, we use a method from the list class or list collection that is called sort. And this is actually defined by an interface. And this is called comparable. The elements of your list must implement comparable so that you can actually call the sort method on the list. But I want to draw your attention to two restrictions here. First thing is, there are some restrictions that apply to this rule. We're going to see next that some objects do not actually implement comparable, but can still be sorted in the list. Also, another important part, the sort function here that is part of the list is actually something that works as a black box. There is a sorting algorithm behind it, which allows us to sort elements from the list. But the definition of that algorithm or the type of algorithm is actually not documented. This is part of Apex core. Someone already asked me about this one, and the Apex team is not specific about which sorting algorithm it is using. And it's actually the same thing for Java. The definition of this algorithm is actually quite flexible. That's not something that is fixed in time. They're changing it from time to time. And the way this works is that with comparable objects, with the comparable interface, we get one method, which is called compare_to. It works a bit like equals, except it returns an integer. And what this means is that there can be three values or three types of values that can be returned from this method. It can be either 0 when this current instance of the comparable equals the other object. And here, generally, we're using the equals method. It can be positive if this current instance is considered greater than the other one, or negative if the other instance is inferior to the other. Now, we generally don't need to have specific values, as just +1 and -1 is good enough. There's not necessarily a notion of scale. It's just that the fact that we have three types of values. And the way algorithms work with that is that generally they convert the type of the list into numbers, and then they can do this, call these different calls to comparable to adjust the position of the elements in the list so that it returns a sorted list. Again, I want to insist on the fact that just like equals method, you can use compared to with different types. So in the list, you can have mixed object types. You can pretty well have a list which contains strings, but also contains integers at the same time. And so the compare to method accepts other types. You're not necessarily comparing a string with a string. You can also compare a string with an integer or a string with a date, for example. So that's actually pretty important because in some cases, there's going to be not necessarily casting, but also different comparison between the different types. So let's take a look at some corner cases. As I mentioned earlier, as in the big picture slide earlier, you have to implement the comparable interface when you're calling list.sort. If you don't do that, for example, if you create a class like this, like some class here, which is not comparable, you put it in a list, and when you try to sort that list, you'll get a runtime exception, a system list exception that will get thrown to you. But as I mentioned earlier, there are actually exceptions to this rule, and two of them are very important here. The primitive types, so things like lists, not lists, of course, but string, integers, dates, float, double, IDs, all of these primitive types do not need to implement comparable. In fact, they do not implement comparable. And also the different sObjects, they do not implement comparable directly, but you can sort accounts, opportunities, etc. in a list. Now, I'm going to cover these specific types of objects because they have their own sorting rules. So let's just talk first about primitives. Primitives are ordered according to something called natural ordering. And this is coming again from the Java world. It's not specific to Apex. Here, I've put a little example, which is a bit extreme, I should say. I don't think in the real world there would be really practical applications of this. I've created a list of objects in which I've mixed almost all the possible types of primitives. So here we have, for example, an integer. We have a double here, a Boolean, a null type, some strings, a long type here, a Boolean again, and a date type. This is not the full list of all the primitives. There are others. But here you can see that I can call list sort on this list here. And of course, again, these objects do not implement comparable, but they can still be sorted. And in the end, this is the result that you get. I don't think you can do anything really practical with this, but I want to highlight the fact that the ordering is defined by certain rules. And there can be some pretty nasty things that you wouldn't expect. So for example, 4 here, which is the integer, is actually returned before the double value here, which is normally inferior to 4. It should be lesser than 4. And same thing, you have other types here like false at some point here and true later on after another value. So that's very, very strange, but that's the way it works. And there's a general rule about the way natural ordering works. First of all, there's going to be a type sorting. So there are going to be categories of object instances based on their types. The null types is always the first one. The Boolean comes after that. But the Boolean is special. The Boolean is a bit of an exception because you can see the false value is separated from the true value. And after that, there's going to be the integers, doubles, Boolean, true, and long, date, string, etc. So the list is a bit it's a bit strange, but the generally it's grouped by types. And then after grouping by type, it will compare the different values from the similar types. And the ordering after that is based on the definition of this type. So for example, for numbers, it's a numerical ordering. For strings, it's called lexicographic. It's not just alphabetic because there can be also specific characters which are not part of any alphabet, like commas, colons, dots. And finally, there are dates and time types, and this will be chronological ordering. So really remember that the first thing that works is that type sorting and then value sorting. This is true also for custom objects. Remember that the two things are separated. Here I've given you for reference the list of different object types in the way they are ordered by default. Again, there are more primitives than just that, but just to give you an idea. Another thing that is also specific, this one to Apex, is the way sObjects are ordered. You can check out the Apex developer guide. This gives you a bit more details on what I'm going to share, but here, this is really the highlights. When you compare the different objects in the list, so if you try to sort a list which contains opportunities, accounts, and contacts, for example, the list is going to be sorted first on the label of the sObject type. So for example, accounts starts with an A, so it will be first in the list. Then there's going to be opportunity contacts because it's a C, and then opportunities. So this is the first level of sorting, the type sorting. Then it's going to use the name field if there is a name field, because some objects do not have name fields. And finally, it will look at the list of standard fields, except for ID and names, and it will take the list of those fields in alphabetical order. So this way, for example, the industry field will be taken before the ratings field when you compare values from similar objects, similar account objects. And finally, in the end, it will kind of apply the same rule by looking at custom fields in the alphabetical order when comparing them. Now, what's interesting in the way it compares the objects is that it will not do all of these things. It will stop at the first inequality. So as soon as there is one of these checks which returns a non-equal value, it will stop the algorithm and actually be able to order the objects. It won't run through all the standard fields or run through all the custom fields. It will stop at the first difference between the field values, between the two objects. So that's, in a nutshell, how objects can be sorted, sObjects can be sorted. Let me now talk about custom types. That's really, I think, what's even more interesting for us. And for, actually, yeah, before I jump into custom types, I want to talk about how you can actually order for custom ordering sObjects. There's one important thing with sObjects, which is kind of problem for us when you want to extend them, is that you cannot directly extend them. So you cannot actually overwrite or implement a comparable interface on an sObject. You can do that because the sObject type is not extendable. You cannot inherit from it. So this means you cannot add the compare_to method from the comparable interface if you want to sort them differently than the default sorter that I presented. The solution to handle that is actually to write a wrapper class. So for example, here you would have a sortable account class, which implements comparable, which would contain an account property. So here I've used the UML syntax. For those of you who are not familiar with UML, minus means private and plus means public. So a private account, which is the account that you're sorting, and then public method, so a public constructor for this class, sortable accounts, in which you pass the accounts, which will be stored in the property of the class, and of course the compare_to method, which returns an integer. So that's how you would sort accounts based on a custom type, on a custom ordering logic. That's the theory. Now let's actually jump into VS Code and let's see that in practice, because looking at the schema, I think is not enough to understand how this works. So I'm going to jump and show you some code. All right, so there we go. And I want to show you this sortable account a bit expanded. All right, so as I mentioned, we have our class, our custom class, which implements comparable. So this way we have access to the compare_to method. We have a private property. Here I've also made it final so that we cannot change it. We're only assigning it once with a constructor here. And then we have the interesting bit for our object in the compare_to method. So the compare_to method works exactly like the equals method work. It returns 0, 1, or -1, depending on how we compare with the other object. The first check what we need to do is the type equality. In my implementation here, I've specified that you cannot sort this with another object type. So if you were to mix my sortable account with, for example, an account, this wouldn't work. I would throw an exception here. I will only sort a list that contains sortable accounts. It's important to make the assumption that you're actually comparing with the right type. Sometimes I've seen in the Apex documentation, they're forgetting that check here to check for the type and directly casting other object to the object that is being sorted. That can be dangerous, so I recommend most of the time to do a little check here with an instance of to compare the different types. That can save you some headache when you're doing operations like equals or compare to with mixed object modes. Then I'm actually converting my other object into a sortable account. Now that I know that it's also an account, a sortable account, and actually I'm writing my operation. So for this example here, my sortable account is using the shipping country field, and I'm just using a lexicographic comparison here, looking at whether they're sorted alphabetically or not, based on the shipping country value. So that's just an example. I could use any field. I could also tweak this object to look at different sorting fields. Now, this is the basics. But now, if you do that, when you want to sort this, when you have a list of accounts and you want to sort it, you would have first to convert all of your elements of accounts into the sortable account type called the sort method, and then reverse go back to the sortable to the account type. So that's actually adding a bit of overhead on your list. What I recommend that you do is actually write a little method here, a helper method, which is not in the schema that I shared in the slides, but it's actually quite helpful. Write a static sort method that can directly work on a list of accounts. This way, you do not have to deal with the conversion between accounts and sortable accounts. You can write the logic here, which will turn your list of accounts into sortable accounts. So that's actually simple boilerplate code, which does a call to the constructor. You can actually sort your list there. And the nice little trick here at the end is actually super valuable here. Instead of returning our sorted list of accounts here, we actually are overriding the input parameter. So we are overriding the account list here so that we do not have to return it. And this actually helps us reduce the amount of code we have to write to call our list sorting. With that, our calling code can just be something like sortable account, sort account list. And after that, the list is sorted. You can just use it directly. That's actually super useful because we're able to overwrite the list here that is being sorted. Just like when you're calling account list directly and sort, you do not have to retrieve the output parameter of the method. You do not need to do acc list equal. That's not needed. The list is sorted in place. It's already overridden with the right order. You do not need this. And by using this little trick that I wrote in sortable account, this bit here, we're actually overriding the input parameter, the account list, to replace it with the sorted list. So calling our list can be very simple. So that's really the basic. All of this code that I shown here is in a GitHub repository. I will give you the link at the end of the presentation so that you can actually get more detail and even try it with your own sorting algorithms. Now back to the slides. I want to show you something else now. So that's already quite convenient. You have a wrapper and you can have you can sort sObjects this way with also this utility sort method directly on the wrapper object. But what if you want to sort a custom type, which is not an sObject? Well, you can actually work a bit differently. You can work with something that is called a comparator. This is actually something that I haven't invented. It's part of the Java language, but unfortunately hasn't been brought to Apex. And it's something that you can actually do yourself. You can actually bring this comparator interface to Apex by running it yourself. It's quite simple. And the reason why we use comparators is that list.sort is limited. There are two important limits to the way list sorts work. First of all, the ordering logic of a list sort is tied to the comparable object. So for example, when you do a sort on accounts or sort on strings or dates, for example, you do not control the sorting logic. It's actually defined not at the list level, but at the object level, whether it is an account or a string. And so you cannot really change your strategy. It's tied to the object that you're sorting. There's no way to pass parameters or to change it. So if you want to sort the same objects, but in different ways, you're stuck because there's only one possible way of sorting. With comparators, this is a workaround. You can actually sort with different strategies and parameters. And the implementation is actually quite simple. The interface of comparator is actually something that moves away from the comparable object. It provides a compare method, which returns an integer, just like compare to, but instead of using this, it compares the two objects separately from the comparator instance. So you compare object one with object two. And the way you call it is actually by providing your own sort implementation, which is bundled generally in the utility class, for example, ListUtils, whatever you want to call it. And to this sort method, you pass two things. First, the list that you want to sort, and then the comparator that you have defined. And with this structure here, you can create your own comparators. You can use multiple comparators on the same list of objects. So you can sort a list of accounts in different ways, for example, or a list of strings, or a list of dates, etc., with different comparators. And you can also pass parameters to those comparators because you can have custom constructors with those. Let's see some examples. So going back, oops, actually here, they're here, but I'm going to show the code a bit further later. So here you can see how flexible the comparator interface works. For example, in the first example here, I have a list of accounts. And instead of doing my the logic that I just shared with you earlier, instead of writing the sortable account class and having all of the wrapper code, I can actually provide my list and write a custom comparator. Here, this comparator is super generic because it works with a string field. And you can actually pass the string field that you're ordering with as a parameter. So you can see that I'm reusing the same sObject string field comparator, and actually I can sort my list of accounts with two different things. On the first example here, I'm sorting based on the shipping country. And in the second one, I can actually sort based on the industry field. So this is really the power of comparators. You can have the same comparator, but with different parameters to provide different sorting strategies. And not only that, you can also write completely different comparators, like this one, for example, the account rating comparator, which will actually take a field value and order it with a custom ordering. And this one in particular is looking at the rating pick list field, and it's actually sorting the values of the accounts based on the order of the pick list. So remember, the by default the rating is I think it's hot. It's hot. I forgot the values. It's hot, warm, or cold, I think, something like that. There are three values, but the values are not ordered alphabetically. They're ordered in the importance. So hot, of course, being the most important one, warm, and then cold. And so with that, you can write your comparator, which would sort the accounts based on the list order provided in the pick list definition. So let's take a look at how this works. Going back to Apex, to my Visual Studio Code, I'm going to take a look at my little class here. And first of all, I'm going to take a look at the ListUtils utility class. So there's a bit of code. It's not easy to write. And this bit here is actually a bubble sort. There are different sorting algorithms in place. It's not something I even wrote myself. I just grabbed it from a Java example. And this is something that will sort a list of numbers, and it's quite efficient. It's a simple sorting algorithm, and it's quite efficient. Of course, there are tens of different sorting algorithms. Depending on what we want to do, you can decide to use a specific algorithm. But what I want to explain now is the logic behind this. It's just that there is a sorting mechanism, and sort can just handle the list of objects in the comparator. Now, what's interesting is that there is a definition also of comparator here, which compares the two objects, and an exception if something goes wrong with the comparison. Now, you can just use this list with the bubble sort that I wrote here, and you can also choose to use over-sorting algorithms if needed. This one is quite efficient. Generally, it's good enough, but you can extend it if you want something else. what I want to spend more time on instead of looking at the sorting algorithm is actually looking at the comparators. So I'm going to take first the simple one, the account rating comparator. The account rating comparator, as you can see here, implements our comparator interface. And this means that it must provide a compare method. It's actually defined here at the bottom. In my case, I built a little cache of the different rating values, so that I actually retrieve account rating values only once, and I can then use this cache there after to order them in the right value, in the right order. And what I did also to simplify the sorting is that I converted the string values into integers. So hot being number one, hot being number 0, warm being number 1, and cold number 2. Sorry. So this is an easy way. And generally, when you're sorting, the first thing you want to do is grab your values and try to bring them down to an integer, because it's always easier to sort a list of integers rather than sorting a list of strings or dates or etc. So that's generally the first operation when you're doing a sort, convert to integers. And after that, there's the compare method. The compare method first checks that our two types are compatible. Again, it's just the same thing as you would have in a comparable interface. You're making sure that object 1 and object 2 are the same types, and they are indeed accounts. I don't want to sort other things in my case. Then I get the values of my rating fields, and then I do my little comparison. If it's the same value 0, if value 1 is greater than value 2, 1, or otherwise -1. Simple as that. So with that, I can just skip this part. I guess it's just getting the value of the rating using the map that has been cached and retrieving the integer. And with that, I can sort my objects by using the rating field. So that's already quite powerful, but last thing I want to share with you is the sObject field comparator. So this one is a bit more complex because it works with any kind of fields. It's also a comparator, so it implements comparator. And yeah, and we save the name of the object here when we create the comparator in the constructor, and then we make first a check that this is the same. These are sObject field. These are both sObjects. So in this case, with sObjects string field comparator, you can actually compare different types. So you can compare, for example, accounts with contacts. It's not as strict as the other type. We're casting our two objects into sObjects. And finally, we are retrieving the values for our field. These are supposed to be string fields. Here, that could be exceptions if these are not string fields. So for example, if we were using fields which map to a date or map to a number, we would get exceptions. I haven't done the check here. You probably want to add those checks here. And then we're doing the sort logic to compare the two strings. So that's how you would work with comparators. It's pretty flexible. I really enjoy this format. It's not like I sort things every day, but I think it's a very helpful pattern. That's a wrap with the different resources I wanted to share. I'm going to give you some links here. The first one is the repository, which contains different classes that I shared with you regarding sorting with Apex. It's on my GitHub repository, github.com/posial/apex-sorting. And then the other types of resources are more documentation. I've shared short codes, short URL codes, so that you can get them quickly. There is the Java documentation, which contains a lot of information about the basic types. So you can read things which are true for object. For example, looking at the equals method or the hasCode method. You can also find information about the way maps work, sets as well. Then there is the Apex Developer Guide and the Apex Reference Guide. So the Apex Developer Guide will tell you tips and tricks about, for example, the way sObjects are sorted by default, for example, or natural ordering. And the Apex Reference Guide will tell you things about the way the maps, list, and set work with the different methods. That's a wrap for all the different resources. I'm going to check the chat now, see if there are any questions. Feel free to type in your questions. I'm going to check. All right. Whoa, quite a few questions here. I've been a bit less careful to read them in the chat. All right, let's see. Okay, back to the iterators. If the iterator is accessible in read-only mode and locks the collection, does it mean that we cannot modify the collection if we use iterator? Yes. So as I shared earlier, you have to get rid of your iterator instance in order to be able to modify the collection. As long as you have an instance of the iterator that is in your runtime, you cannot touch the collection. You cannot remove things. You cannot add things to the list. You need to get rid of the iterator, for example, assigning it null, that will unlock your collection. Okay, someone is looking for Apex developers, good. When would you use when would a comparison return less than or greater than? So that will actually depend on the type that you're comparing. Again, I want to say that it depends on the type that you're sorting. For example, when you're looking at strings, you're using something called the lexicographic order. So this is basically looking at the character codes of your of the characters that are part of the string and comparing them. If it's a date, generally it's a chronological order. So basically converting the two dates as timestamps and comparing those timestamps, which are integers number or actually long numbers, and compare them. So it's actually a numerical comparison in the end. And there are also all sorts of different comparison rules that you can use. What else? Yeah, good question. So can we implement comparable to get ascending or descending order? So no, you cannot use, that's actually one of the limitations of the comparable interface. You cannot not pass parameters to it when you call list sort, for example. So that's a limitation. Now, having a list that is in a sorting order or descending order isn't really one of the key advantages, because you can actually reverse the list quite easily. Instead of starting with element 0, you can start iterating on the list from the last element. But if you're working with comparators, well, you could as well have a Boolean in the comparator definition that lets you actually order the list in one order or the other. So that's one of the advantages of having comparators instead of using the comparable interface. What else? Good call. Yeah, it's someone mentioned that it's generally not a best practice to modify a parameter received by a method. I agree. Most of the time, it is not a good practice, and you should refrain from it. But I think there are some exceptions to it. As long as these exceptions are documented, there are some leeway for this. And the reason why we're doing it with list sorting is that it's something that can be quite verbose for a simple operation. So I think most of the list methods are actually working in place. So for example, when you do list sort, it's actually doing it in place. So I think it's kind of a pattern, and you're not really doing something surprising by sorting the list in place. It's kind of the same behavior in the original list sort. So I think you can make an exception for this one. Of course, I wouldn't recommend it in a service, for example, in a service which takes a lot of different parameters. I would not recommend to overwrite the input parameters. That's generally not something you want to do. But for this kind of use cases, I think it's okay. And yeah, I agree, is code scanners will generally flag this as an issue. And this is why you can actually have exceptions to this code scanner rules. But as long as you document it, I think it can be fine. Thanks for the shout out. Thanks, everyone. I see a lot of thank you. Thanks you, everyone.